I'm a software engineer at InfinityWorks, and beginning this is actually the hardest bit because everyone has nice titles to put on there, like principal software engineer, tech lead, team lead, and I used to be, but truth is now I'm just a bloody contractor, a consultant. I'm the guy who comes in for 6 months and then leaves, and you're remaining there to deal with the mess, the technical debt, and all that stuff. Although, it doesn't have to be that way. In fact, I was lucky enough at my current place to start as the first person on a greenfield project, which made me the de facto team lead. We got a couple of people in now, and it's a lot of responsibility. Like, the choices I made at the beginning of the project would essentially shape the project for the coming months, and any mistakes would have been the frustration of people joining in the future, right? So I wanted to get it right, and because it was a Java-based project, the way it looks nicely nowadays would be something like this. It would be probably Spring Boot, microservices on Kubernetes. And then I started building it and I thought, is it really microservices? Because anyone who has used Spring Boot, yes, it's much better than the legacy we had from 15 years ago, like enterprise Java Beans and all that crap. But it's big. Like, typically in a Spring Boot service, you might have Spring MVC if you're doing web stuff, Spring Security, Spring Data, maybe Spring Cloud, which has lots of useful stuff. Spring Data brings in Spring AOP, and especially if you're dealing with a relational database and you use Spring Data JPA, that is really huge, like really, because it has Hibernate, and Hibernate is a huge beast. Oop. So just to show you how this works, this is a jar with Spring Boot and just web and security, 18 megabytes. Just by adding Spring Data JPA, that's almost doubles, which is insane. So it's definitely not micro, as you can see from this startup time, right? So I want something small. If I think about hibernating animals, I want these cute little things. And I did find something like that. It's called Juke. In a way, it's an alternative to just using raw JDBC. The way it works, it's pretty nice. It's not perfect, but it essentially, you can launch a Gradle task. I mean, you can do it with Maven, but it's 2019. And it will, after you run your migrations, it will scan the tables on the database. It will essentially see your schema and do some code generation, Java code generation. The result is something like this. You get a DSL, a Java DSL, that you can create queries with. You see that book table, that object there is like a public static final something somewhere that Juke generated. So you can reference all the columns in a type-safe way. You don't have to deal with strings as column names. And it's really nice. You get all the operations like where, and, equals, and all that stuff. And it's safe at compile time. Like, you can write a query that does the wrong thing, but you cannot write something that doesn't work at runtime, like produces a wrong query or queries a column that doesn't exist, which is really cool, especially if you start Spring Boot in like 10, 15 seconds. And you can do really complex stuff, by the way, which is much better than the JPA specification API. So what does this have to do with APIs, contracts, and versioning? Well, thing is, what is it that makes this code generation possible at all? Well, schemas, right? That's the whole thing. So essentially, you can view the SQL schema as a contract, like each field has a type, constraints we have, you even know which fields indices exist, so you can query your data in an optimal way. You can do pretty much the same thing with REST APIs. There are lots of description languages that you can use, like Swagger Open API. You could even use RAML or JSON API. And many others. This is an example of Swagger UI. I guess most of you already know about this. This is the pet store example. They claim it's a REST API, although I have a few doubts. But anyway, this is how a Swagger file looks like. So essentially, you kind of describe your API requests and responses. You give it a schema, which then allows you, like, this is how a user looks like. It has an ID, a username, etc. You can even use annotations. This works at runtime with reflection. So if you have a controller and a response body, it will scan the Java classes and produce the Swagger file, so you get your Swagger UI. Yeah, the cool thing is that you can generate code for the client. You can also generate code for the server, which is something I strongly recommend, because doing it like this is essentially asking for trouble. And this is an example. You have this order detail, ID, purchase date time, amount. The purchase date time is zone date time. If you just serialize this with your Spring MVC, that will use probably Jackson's object mapper, which is configured in a certain way, and it will serialize the date like this if you're lucky enough to have your server in UTC, which should always be the case. But if you have something else, or did some manipulation with the zone date time, it could serialize like this, which is not a valid ISO date format, and it will essentially crash any, say, JavaScript client trying to map this to a date. So boom, you break things. Even though you have a schema, you might still break things if you don't use the code generation, because if you do use that, then you're guaranteed to use the exact same serialization and deserialization both on the client and on the server. So a way to catch these kind of issues, if you don't use code generation both ways, is contract testing, which is essentially a way of verifying that throughout a communication channel, the producer and the consumer, they adhere to the same format. So it's very useful. You can do it client-side. So let's say we have a Java service which integrates into some other REST API. You can use OKHTTP mock web server, which is really nice. You can make unit tests with it. You can assert that you call the right URL, that you pass in any headers you need. You can intercept the request and do all these assertions. You can even mock the response, which is useful for unit testing. And on the server, we all do stuff like mock MVC from Spring or rest assured, and we just check that the body adheres to the contract. There is an even cooler thing we can do, which is called consumer-driven contracts, CDCs. There is a very famous tool called Pact, which is really nice. But I think many people use it in a wrong way. Like, they use Pact as a way of catching if we actually broke something in our contract, which to me should never be the case. Again, there should be something in the way we do this, like in the code reviews or in the code generation, that actually does not allow us to break things. So the best way to use Pact is it's essentially a way of tracking exactly each client, what API endpoints it uses and what fields it requires from those endpoints. So for instance, if you have, I think it's called a pact broker, essentially you can publish all your pacts and expectations to this broker, and you will know exactly, you can track your clients essentially, which is great. This is how it would look like if you did define a pact in Java, for example. And as you see, there is this client which requires just ID and purchase date time and doesn't really need the amount, which allows us to essentially remove the amount in a safe way if we need to evolve the API or change it, say, to long because we don't like big decimal. Just never change it to float or double, please. So, but can we avoid contract testing at all, which will be cool, because there is a lot of effort in doing that. In the end, what we really want is we don't want to deal with HTTP clients and all that stuff. We just want to call a method somewhere and get the result, right? There is a very easy way of doing this. There is lots of tools out there like protocol buffers from Google, Apache Thrift, Apache Avro. And what all of these tools do is essentially they serialize in a binary format, and they heavily use code generation then to allow creating both clients and servers. So this is protobuf from Google. It's a language neutral, blah, blah, blah. In a nutshell, you define a contract. It's the message person, required string name, required int32. You can have an int64, so it's very precise, etc. And then if you do generate the code, this is an example of Java code, you have a builder, and then you can send the bytes through a stream. So how do you use this on a microservices environment? You can use remote procedure calls, which is something you can do with Google RPC. It's pretty cool. So this is, if we're using protobuf 3, we can define messages and services like this. Let's say we define there is a remote procedure, which would be like, as a REST endpoint. We get the point, the value, and the As a parameter, we return a feature, and code would be generated for all of this, essentially. In our case, in Java. We put that Java code in a Maven repo, and we embed it in clients and in the server too, actually. This is how a server would look like. As you might notice, it can do some asynchronous stuff. So very simple, this would be instead of your REST controller. And this is how the client would look like. You can create a new blocking stub or non-blocking stub, and then you just call the method. You might have to catch a status runtime exception, which is kind of like catching 400 errors or 500 errors in a REST API. And it's very performant because it's binary. So there's no overhead of serializing and deserializing all the JSON. So apart from remote procedure calls, which essentially might replace your REST APIs within your microservices, obviously you would still have an API gateway, maybe exposing a REST API for iOS, Android, web clients. But internally, is there any other use case for this binary serialization? Actually, yes, we can use it for message queues too, which is where Avro comes in, which is really cool because it plays really well with Apache Kafka. In fact, Confluent has created an Avro serializer and deserializer for publishers and consumers on Kafka to send and consume messages. It works in a similar way. You just define a contract, a schema, and then you have generated code, which makes life easier. So pros and cons of these binary formats. Obviously, binary formats are non-human readable, and maybe not all programming languages are supported. I don't know. Any new programming language, you might not find a Google RPC code generator, so that might be nasty to use, but REST in the end, JSON, it's really easy. Pros, well, better performance, as mentioned. It's strongly typed format. It's very precise. It's very hard to break things. And usually there is a standardized versioning strategy, which we will see. And that's really the interesting bit, because in the end, nowadays, we keep evolving our APIs. They always change, and we need to do these changes safely. How do we change stuff, right? I guess there might be a few companies out there with 30-year-old COBOL software running on a mainframe that if you say, let's change this, you will get this reaction. But nowadays, most of us are agile companies. We iterate quickly. So usually, changing stuff, yeah, Chuck Norris approved. We just need to avoid, breaking things. How to do that? Well, there's a very simple way, which is never rename or delete a field name or the format of its value. That's rule number 1. Rule number 2, never rename or delete a field. Rule number 3, never, ever, ever violate points 1 and 2. And that's all, really. I mean, that's a perfectly valid strategy. You can do it. Just keep adding fields, keep adding new endpoints, never break any of the existing stuff. But if we do want to make changes, let's see how we can do them. What kind of changes we have? We can rename delete a field. We can change a field's format. We could add a field. We could add a new value to an enum. We can upgrade or remove a service endpoint or remote procedure. So in a REST API, use case renaming or deleting a field, that's a perfect use case for Pact. Is that field used by any client still? No? Okay, go for it. Yes, we just need a new version of that API, right? Changing a field's format, upgrading, removing an endpoint, it just begs for a new endpoint version. That's not something you can really do. Adding a field is usually safe. There's a catch. You need to make sure that the client ignores unknown fields, which is usually the default behavior. But again, if you use Spring and Jackson, it might not be, and you need to set one of these annotations or configure the object mapper in this way. So really be careful in the client. Adding to an enum, that's the most dangerous thing, because essentially you would get an invalid format exception from Jackson if it tries to read from a JSON that contains a string that it cannot map to a known enum value. So there are a few ways of doing this. Actually, a few tricks, a few workarounds. First of all, you could just use strings, option 2, and not use enums. That's perfectly valid. Or you could set Jackson to read unknown enum values as null and check if you do get a null and do something with it rather than getting an exception. a way to do this in a slightly smarter way, if you can allow your endpoint to just transition to a new version of the API, let's say in version 1 you just had 4 reasons for a failed transaction, insufficient balance, limits exceeded, account blocked, actually 3 reasons, but you're smart enough to insert something like other, which is any other reason really. In the V2 of your API, you actually thought, okay, so there is another reason, which is duplicate payment. We can expose that to any clients that integrate into the API V2, but any client requesting API V1, what we do is we map duplicate payment to other, so we don't break them. In the case of Google RPC, there are a few very nice use cases for changing a field's format. Well, adding to an enum and upgrading, removing, it's just a case of, you have a V1 version of your message, and then you make a V2, and that's pretty much it. Same thing for the remote procedure, so that's quite easy, as you would do for a REST API. But if you want to rename a field or add a field with Google RPC, it's really easy, because actually the fields are not identified in the format by the name, they're identified by that number you see. So if you want to change longitude to my longitude, it really just references still number 2, so you don't break the clients. You just have the new code generated with the new name, which is cool. And then if you need to add a new one, that's number 3, and that's it. And the format itself guarantees that clients won't break with these kind of changes. Avro, that's pretty cool if you use it with Kafka. There is a thing called schema registry, which you can configure to essentially refuse if you publish any new schemas that are not backward compatible or forward compatible if you need that too. So yeah, backward compatibility means consumers using the new schema can read data produced with the last schema. Forward compatibility means data produced with a new schema can be read by consumers using the latest schema. Actually, it's much more complex than that. You can have these transitive compatibility types, so it's really nice, gives you a lot of flexibility. You can check it out on the Avro documentation. In terms of versioning strategies, so until now we covered how not to break things, but if we do end up needing a new version of the API, like in those cases where it just was inevitable, if it's the whole API, you just change V1 with V2, easy, but if it's a single endpoint, we don't want to do that, right? And probably we don't want to do something as ugly as this either. It's just horrible. V1, users, V2, nah, all right? A way we can do this, we can use the HTTP headers and the content types. So in this case, the client is accepting application JSON, but when we do the version 2 of our API, on the server side, we can essentially check, is the client using application, accepting application JSON, or is it accepting the V2 of my representation of my entity? This is essentially the vendor content types. It's a kind of standardized thing. Until application/VND that's standardized, then you put anything like my company.v2, .v3 if you need to iterate over. So that's pretty cool. Another cool thing is database migrations. We spoke about versioning an API and not breaking things, but also the database schema might need to change quite often, and there's a question of how to change it safely. And the trick is, I really hope you're doing database migrations with tools like, Flyway, Lookybase, not doing anything manually. And if you do use them, the trick is usually to make changes atomic or idempotent. What that means is, if this was a single change set, a single migration, something nasty can happen. The first one goes through, you alter table users, you add a column, easy, done. Then you try and create a unique index. Sorry, I forgot the unique keyword. It should be in there. But let's say we did something wrong. It worked in dev, but in production we actually had 2 users for some reason with the same national insurance number. So that query won't run. The migration will fail. And if we try running it again, we're kind of stuck because it will try running alter table again, which will fail. And so you're stuck in this loop. You have to manually change stuff in the database, which you wanted to avoid in the first place. So you need to make this atomic. So these need to be 2 different migrations. Unless your queries are idempotent, which means you can run them multiple times with the same effect on the database. So even if you fail at the second stage, the first query can be run again, because in the end, it just sets the first name to varchar 200 again. Enums, again, they are bloody dangerous. If you have a Java enum, not a database enum, on a database, it's just a varchar. But on Java, you have, in one version of your application, you have just 4 states for a transaction. In the newer version, it's 5 states. And I assume you're not doing downtime deployments, so you might be doing something like rolling updates, blue-green deployments. So essentially, for a transitional period of time, the V2 of your service is running and taking requests alongside with the V1 of your service. And V2 might be persisting that new enum value in the database as a string, reversed. But then if V1 tries and read that record from the database, it cannot map to the enum. Boom again. So that's really nasty. A way to deal with this issue is, oh yeah, that's my boom. I missed the effect. The strategy to use in this case, if you do blue-green deployments, is in the service V2, you actually add the new value to the enum, but you don't use it in any business logic. You never persist it to the database. Then you deploy a service V3, which will run along with a version 2, and that will start taking requests and start storing that new value in the database. But then V2, which is running in parallel, will also be able to understand it. Might not do anything with it, but will not crash. So can we even do breaking changes like renaming a column? That's a proper breaking change. So how do we do it in a way that we don't just bring the whole system down? That's slightly more complicated, but still doable. Essentially, let's say we have a user service and we want to rename column X on the users table to Y. So we have a Java class user. We need to change the field X to Y. Service V2 Service V1 will know nothing about Y. Service V2 will know both X and Y and will implement logic to read either from X or Y. Something like if Y is null, use the value from X. And it writes to both X and Y in any new business logic. Stage 2, we deploy a service V3, which then runs a migration to copy over all values in the X column to the Y column. So now we guarantee that there is no Y column which is null anymore, because service V2 actually stores onto the Y column. At this stage in service V3, the Java user class only has the Y column, so we don't know about the X column anymore. Last step, we deploy, it's a mess, but it's the only way to do it without downtime. The service V4 runs a migration to drop column X. That doesn't break V3, which is running in parallel, because he only knows column Y. And that's it. Done. Hope you enjoyed it.